In this video, we'll be doing methods of differentiation. First, we will learn how to differentiate polynomials. So for example, but before that, let us learn how to differentiate constants. If y equals to 4, your dy dx is equals to 0. Okay, y equals to any constant, maybe 8, your dy dx is still 0. Okay, because when a graph like that will look like this, right? Y, x. If y equals to 4 means y is always 4. Alright, so wherever x changes, y doesn't change. So it's 0, there's no change in y as x changes. Okay, so second is we differentiate simple polynomials, which is like y equals to 3x. So when y is equal to 3x, it's just equals to your dy dx is just equals to 3. Just take the coefficient of the x, okay? So let's say let's say y equals to 6 of t, dy dt is equals to 6. It just sees how it changes, right? Okay, so this is one thing you need to remember, differentiating simple polynomials. Okay, now if you have things that are of higher power, so y equals to 3x squared, all you need to do is to take the power down, so bring the power and multiply it. So 2 times 3, which is, 3 is already here, and then put the x back and decrease the power by 1 after you bring the power down. So bring the power down, then decrease the power by 1, equals to 6x. Because 2 minus 1 is 1, x to the power of 1 is x. And an example for x cubed. By the way, this is your dy dx. So for dy dx is equals to, bring the 3 down, that's 3 times 4. Right, 4 is here, so 3 brings down times x. Decrease the power by 1 to get 12x squared. Even if you have negative numbers, if for example y is equals to 2 over x squared, okay, it's the same as 2x power minus 2, right? So dy dx is equals to bring the power down, times 2, decrease the power, you get minus 2 times minus 4, because 2 times 2 is 4, x to the power of minus 3, which gives you minus 4 over x cubed. Okay? And what if you have chains of polynomials, so like from the y equals to 3x squared plus 6x plus 9. The dy dx, if it's plus, if it's like one term, plus one term, plus one term, like it's just plus in between, you can separate them out into like that. The ddx of 3x squared plus ddx of 6x plus ddx of 9. Now you might be a bit confused by what this represents, right? But this ddx just means you differentiate this on its own, okay? Just differentiate this. This means differentiate this on its own, differentiate this on its own, differentiate its own. So differentiate everything on its own, you get 6x, because this 2 brings down, right? So let me just write out in steps. So bring the power down, remain the coefficient, x, decrease the power, this is just x, plus, this is, remember, plus 0, because differentiating constants gives you 0. Okay, so you get 6x plus 6. Alright, okay, so this is, now how about what if you have a little more complicated polynomials like 3x minus 4 squared? Okay, what you do for this is you can expand and differentiate it like what I did before, but one more method is you just take the power down, okay, keep what's inside, but decrease the power, because now this square represents this square is the square of this, right? So if you bring the power down, you just, okay, and decrease the power, you decrease the power for everything, for this whole thing. So it's like that. And one more step is differentiate what this is. Okay, differentiate the inside. Okay, and when you differentiate the inside, you actually get, if I differentiate the inside, what I get 3, right? Because this is a 3 minus 0, because differentiate 4 is 0, it's a constant, you differentiate this, you get 3. So multiply by what you differentiate inside, which is, in this case, 3. Okay, so I get 6 times 3x minus 4. Another example, we have y equals to 1 over 6x squared plus 2x to the power of squared. Okay, you can write this out as 6x squared plus 2x to the power minus 2. So what you do again is bring, since remember that this is the power. The power is the power of the whole thing, right? The whole thing. Okay, then you can bring the power down. Keep this. Decrease the power by 1. Okay, which gets even lower. And then multiply by what you differentiate inside, which is I'm just gonna write here ddx of 6x squared plus 2x. You get 12x plus 2, right? Because this 2 brings down 2 times 6, 12. The power decreases by 1, so 12. X is x, so 12x plus 2. So multiplied by 12x plus 2. So your answer for this, I'm just not to confuse you and drawing like that. Okay, your answer for this is then equals to minus 2 times 12x plus 2 divided by 6x squared plus 2x cubed. Because this is you bring down to the denominator, right? This is my power minus 3 times power 3 in the denominator. Yeah, so this is basically how you do polynomials. Okay, just remember that if it's inside, it's a bit more complex, you need to differentiate inside. Okay, just one more point. Remember, just now I told you like y equals to 3x squared. Just bring down the power, right? Yeah, it's because it's something like that. Okay, it's a 3. Okay, then multiplied by x squared, right? So when you differentiate the x squared, it becomes 2. You bring the 2 down. Okay, then keep the x minus the power minus 1 plus x, right? And actually you're also differentiating the x inside. Okay, but when you differentiate x, you just get 1, so it doesn't really matter. Okay, which is why you can do it. Alright. Yes, and lastly, also for polynomials, note that, for example, if I have y equals to 3, again x cubed in this case, okay, now this 3, okay, remember when we did y equals to something plus something and on, your dy dx is, you can differentiate this separately. Okay, you can differentiate this plus, and you differentiate this, right? So just differentiate them separately, and everything you differentiated, you add up together, it is equals to dy dx, right? Now same for, in this case, if you have a constant in front of the variable, your dy dx is equals to, you can just take out this constant, multiply it by 3, and then you differentiate the inside, differentiate this, yeah, x cubed. Okay, which is the, yeah, alright, like I've been saying, you can, how I taught you to solve this was bring the power down, right? Yeah, just bring it down, okay, because you can just differentiate it like that, and then multiply by the constant in front. Okay, so this is the part for polynomials. We go on to trigonometric ones. So for, but before that, we have to memorize three kinds of differentials for polynomials. Okay, sin x, when you differentiate it, it's a cosine x. Cosine x, differentiate it, it's a negative sine x. And your tangent x becomes a secant square x after you differentiate it, which is 1 over cosine square x. Okay, which, just to remember refresher, this means cosine x and the whole thing squared. Okay, so knowing this, let's differentiate, for example, sine 3x. Okay, for this kind of stuff, just differentiate what's inside, bring it out first. Okay, so differentiate what's inside, 3x, you differentiate, just now what we learned, 3, right? Bring it out, bring it outside here, sine. Okay, and then after you bring it out, right, which I've just done it here. Okay, after you bring it out, you see the sign here, change it. So for sine, it becomes cosine. And then keep what's inside. Another example, differentiate what's inside. If you differentiate 4x, it gets 4. Change as according, cosine and negative sign, keep what's inside. Ta-da! Okay, and what if you have more complex equations? How about something like that? Y equals to sine of 3x squared. So again, differentiate inside. Okay, so when you differentiate inside, you get is this, right? Differentiate what's inside first. Differentiating inside, change the sign to cosine because you have to follow this rule, and then for keep what's inside. So this will be 6x cosine of 3x squared. Okay, I'm trying not to get too technical and keep explaining because I really want you to understand this is something so straightforward. You have to get used to it. Okay, just get used to it for O-level levels. Okay, unless you're gonna take maths in future, need derive and stuff. Okay, but now just get used to solving it like that. Okay, in even more complicated ones, maybe like that. Y equals to cosine of 3x cubed plus 6x, right? Same, bring this out, differentiate what's inside, bring it out. So differentiate what's this. Okay, and then change cosine to negative sine, keep what's inside. Okay, just so you can see it's a negative sine of this. Okay, and you get, if you differentiate inside, bring the power down, 9x squared plus 6, then differentiate, minus sine, 3, no, not differentiate, just, copy it down. Okay, so this is your answer for your dy dx. Okay, and okay, one more thing is, what if you have powers in the cosine itself? So for example, okay, I haven't really shown you this tangent x, right? Okay, so let's just do one. Y equals to tangent of 3x, differentiate inside, comes out as a 3, tangent change to secant square 3x, okay, which is equals to 3 over cosine 3x whole thing squared, which is also written as 3 over cosine square 3x. Now, what we'll do is a little more complicated. So for example, if I have something like y equals to cosine square of cosine cube of 4x. Okay, what do you do? First, you can rewrite this if it confuses you as like that, right? It's cosine 4x and you times it 3 times. Okay, so it's the cube of the whole thing. So same thing as polynomials, bring the power down. Okay, I'm just going to use the green to show you what's inside. Okay, so this is this green thing powered. Take the power down, 3, leave what's inside, cosine of 4x. Now the power becomes 2, because you minus 1 to the power, right? So bring the power down, and then differentiate what's inside. Okay, now this is the trick. You always must differentiate what's inside. Okay, so differentiate cosine 4x. It's like that, right? This means differentiate what's cosine 4x. So you can write it out as like that. Multiplied by whatever you're going to differentiate this, it becomes a negative sine 4x, negative 4 sine 4x. Because, remember, bring this, differentiate what's inside, differentiate it out, you get 4. And then cosine, change to negative sine, keep what's inside, 4x. So you get this. Okay, and then you can make it to negative 12 sine 4x, cosine square 4x. Okay, so you can see that the difficulty, actually it's not the difficulty, the tediousness, the confusingness comes from differentiating inside. You must keep differentiating what's inside, right? And so that is the difficulty of this whole thing. Okay, so in summary, you can differentiate complicated things like this. Okay, with a power, just treat it like a polynomial at the start. Okay, imagine this as one whole term, cube. Okay, then take 3 of this term, square. So 3 comes down here, then the power decreases by 1, so it's square. So 3, this one square, times what you differentiate this interesting thing inside. Okay, it comes out, and then you go. Okay, so this is the method of differentiation for trigonometry. Next, we're going to do exponential. Okay, and exponential, goes as such. d dx of first ln x. Now just memorize this, okay? I mean, wait. This is an error. See, y equals to ln x. Your dy dx is equals to 1 over x. Just memorize. Okay? And for exponential, so for example, okay, wait, we do this first, okay? So let's say I have y equals to ln of 3x. What happens? Remember again, you must differentiate inside first. Differentiate inside, you get 3. And then after you differentiate it, just apply the ln changes to 1 over x, right? So it becomes 1 over 3x. So it becomes 3 over 3x, which is equals to 1 over x. Yep, so you get two differentials that are the same. Okay, so what you see is first differentiate the inside, okay, bring it out, so bring it out here, and then the ln, you have to change it to 1 over x. So if it's ln of 3x, you change to 1 over 3x. Ln of 1000 billion x is 1 over 1000 billion x. Whatever this term is, because you see, the ln applies to this thing, right? So you need to bring this down to the 1 over. So if ln in case applies to the whole thing here, you need to bring this down to the 1 over. Okay? Yeah, so this is basically something like that. If you have something more complicated, again, you must differentiate inside. So ln of 3x squared plus 6x. What do? First, again, differentiate inside, bring it out. So for functions, differentiate what's inside and bring it out first. Okay, just like just now when you have sine 3x. Okay, for functions of something, okay, if you have a function of something, you differentiate what's inside and bring it out first. Okay. Oh, oops. Okay, so this is what you do. So when you differentiate inside, you get just write it out. Okay, this means you differentiate inside, and then you bring it out. So you left with a function, right? And remember that for the most basic, okay, then this function changes to 1 over x, right? So this thing, after you differentiate the purple one and you bring it out, you need to change the ln of the function into 1 over 3x squared plus 6x. Okay, and then your answer will be, if you differentiate inside, 6x plus 6 over 3x squared plus 6x. This is your dy dx. If your y is equals to this. Okay, so it's always just differentiating, bringing it out. So one more last example, if you have like mix of functions, for example like ln of sine x, sine 6x. Remember again, okay, now this looks a little complicated, right? But actually it's not, because if you see, first you do the ln, okay, so you need to differentiate what's inside the function, correct? Which is sine 6x, so you need to take it out. If you don't want to confuse yourself, write it like that. So you bring it out, okay, you bring this thing out, and then you now change the ln to 1 over, and since the ln applies to the whole thing, you put the whole thing at a 1 over, okay? And wait, now this is the part where it gets a little complicated, okay? Pause it first. Because to differentiate this, is like you're differentiating another function, right? So you can do this separately, which is sine differentiate of sine 6x. Now use another one. See, now there's another function here, right? Which is sine of 6x. So bring the differential of this thing out first. So you get 6. It's black. Get 6. Alright, then change the sine to cosine. Yes, and then now you get it already. And then 1 over sine 6x is equals to 6 cos 6x over sine 6x, giving you 6 cotangent of 6x. Okay, so this is basically how you do kind of like a ln kind of thing. Lastly, you have y equals to e to the power something. So if y equals e to the power 3, your dy dx is 0, because it's a constant, correct? Remember, differentiate. Constant means if I draw the graph, it's y and x. If this is e to the power 3, always be like that. It's always e to the power 3. Y is e to the power 3. Doesn't matter what x is. Okay, it's always e to the power 3. Okay, now if you have y equals to e to the power 3x, the method to solve it is first, okay, take e to the power something as kind of like a function thing. Okay, so whatever is the e to the power of, okay, differentiate this first. When you differentiate it, you get 3, correct? So I'll just write it out the steps. The steps is d dx of 3x. Okay, differentiate, then keep everything in e to the power of x. No need to change anything, just keep it. This gives you 3 e to the power 3x, because this is 3. Okay? Same thing if y equals to, differentiating exponential functions is the simplest. Sine x. Okay, then you just differentiate what's here, cosine x, and then keep everything. Okay, so you see, you just need to differentiate this. Okay, and when you differentiate, it becomes actually cosine x. Okay, and then you keep the whole thing here. That's all. Alright, so that's basically how you do differentiation. I have given you some examples already. Okay, now the most difficult part of this is to differentiate what's inside of something. So like ln of sine 3x. Okay, you can even make it more complicated. Ln of sine of cosine square of well, maybe e to the power 6x cubed the square plus 2. They're like, what is this, right? It's like you have e to the power of something, you cosine square it, and then you sine it, and no, okay, I'm just going to give you this. You can kind of ignore this. I don't think it'll come out. It's very, very deep in, but this is the difficulty. Okay, is you need to keep on differentiating what's inside. All right. So in this case, you first have ln. Okay, so must first differentiate what's inside. Okay, you just bring this whole, oh gosh, this takes forever, man. It's out here, and then change the ln to 1 over this whole thing. Sine, cosine square, blah 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 blah. Okay, and then after that you want to differentiate this, right? So you again, which is, since this, what you need to differentiate is this whole thing. Okay, you can split it up again, so you open up this whole equation, this d dx of this you can expand to 2, differentiate this first. Okay, so you're gonna write d dx of cos square of whatever that is, and then change the sign to cosine, right? Because you need to differentiate the function itself, and then add a sign here. No, sorry, then add a sign here, and then copy the whole thing in. And then you keep doing on and on and on like that. Just opening up this d dx, opening up more and more until you get a super long equation. Okay, so this is basically how you do differentiation, and the best thing to really do about this is to keep doing practices, because this is very little concept here. It's just all about practice, getting used to doing it, right? Get used to doing things like that, right? And you will improve. And lastly, note that what you have been doing is only for one of like y equals to something of x. Can be a trig, can be any kind of function, but just one x. Okay, we haven't been doing things like sine x times 3x squared. We haven't been doing this yet, right? Okay, we haven't been differentiating things like that. Okay, we will only be differentiating when there's only one like x only appears kind of like one time. Okay, and there's no x multiplying an x. Yeah, a function of x multiplying a function of x. We don't have such thing yet. Okay, so just note that, because this will have to do with chain rule. Okay, you can't just differentiate this and then multiply. Okay, so you cannot do this times. You cannot. Okay, times. You cannot do this. Okay, you cannot just multiply something like that for a chain rule. Okay, for equations like this. So this is the end of the tutorial. Hope you have understood mostly what I've been trying to tell you.